Good morning, everybody.
Morning.
Yeah, morning.
Okay, we'll start going through, let me see something here. All right, let me share my screen. Whoops. I don't need that. Okay, so we are here. We are at the second week. And so in terms of your text, we're in chapter 2. And what we're doing here for Monday and Wednesday are just some basic beginning to get you to be able to install Java and edit, compile, execute, and what that looks like. Now, I'm going to be using console input all the time, and in your labs, you're going to learn about Eclipse. And lab 1 is up now, I believe. I think you got an announcement about that. And everything is due at the end of the week, so you have time to work on that. And Dean is treating lab hours as tutorial hours, it looks like, which is appropriate. So what we'll do here is just start to go through basics of here's what a Java program looks like. To actually, you know, we've talked about it a little bit. What does it mean? What does it really look like? How do you edit it? How do you compile it? How do you run it? And what does that mean? And as always, we'll start with Hello World. Then what we'll do the following week, we'll get into if, then, else, and loops. And then for the week after that, we'll get into methods, think functions, and then we'll start to worry about object-oriented design. Every Friday, I'll have a discussion about some aspect of the project. We'll go from there. So I'm going to start posting project materials during the week this week. If you have questions, by all means, ask them. Okay, oh, you may have a question what this is about. This is from the previous class, so let's get rid of that. Okay, so all I'm going to do today is run some Java programs, play with them, break them, that kind of thing. What I do is I keep mine relatively close to the top of the C drive. So here we are, here's the C drive, and I've made a CS225 folder right there. And then from there, I have all these different examples that I'll use throughout the semester. And here's, I'm configuring them to the new terminology here. So here's module 2, and these are the files that I have. And notice you have 2 types. One is a Java file. That's the file that you actually write. And then you have something called a class file, and they have the same name. So if I do this by name, notice I have circle controller Java and circle controller class. By the way, my sound might be cutting in and out some. If you hear that, it is a known condition. I'm trying to figure out why that is. Maybe it has to do with this table I'm on or something. I don't know. But I think but I'll try to figure out what's going on with that. It's not you, it's me. So I have 2 versions of these files. Now, why is that? Those of you that took CS223 or are used to dealing with a compiled programming language like C or Java or C++, know how this works. If you took the MATLAB class, this may be new to you. MATLAB, what's the extension for MATLAB files? I forget. Is it .m?
Yeah, it's .m.
.m. So you write a .m file, and then the MATLAB will run it. Is that correct?
Yeah, I think it's interpreted.
Right. Remember, think back to EGR 115. So So MATLAB is a translated language. So in other words, eventually everything has to get down to machine code. And what happens in MATLAB is it's a tool that will take your program, and while the program is running, it will convert to machine code. And there's a lot of languages like that. Usually when you hear of a scripting language, they're often in that form. So languages like JavaScript, functional languages like Lisp and Scheme and Racket. You know, there's a lot of languages that work that way. But most commercial use languages are actually compiled languages. And what that means is you instead of running your program, you write your program and then you hand it off to a compiler, and then the compiler will translate it to machine code, and then you can execute the machine code. So Java does kind of an intermediary form of that. It doesn't go down to machine code all the way. It goes part way down. And the reason is that we have something called a Java virtual machine that is going to run your code. So Java's kind of in between those two a little bit. Okay, so let's see. I'm not going to go through the download Java portion of the material in this class. I'm going to leave that up to Dean in the lab. I did cover it in the recorded lectures briefly, and gave you the information of where to go to get both Eclipse and to get the Java JDK, and gave you some information about what to look for on your own files on your computer when you're setting that stuff up. But normally that works well, and there's only a few students that have something weird going on with their machine that it doesn't work out very well. So I'm not going to spend a lot of time on that. I'm just going to jump right into the programming aspects. So this is what this thing looks like in terms of my file organization. I just go right from the C drive. I've created this subfolder called CS225, and then I created module 02. And I'm going to run everything in console. Now console, if you go down in here on a Windows machine, and again, all you Mac people have equivalents for this, and you type CMD, you get the command prompt. Microsoft doesn't want you to know there is such a thing as a command prompt. It lets you get into the guts of the machine. It's a helpful tool. It's so helpful, I use it often enough that I keep it pinned to my desktop. So, command prompt. Now, when it's opened up, its default is in this Windows System 32. So let me talk about if you're going to use command prompt to do some of your programming. And I recommend it. The more things you know how to do, the better off you are. You'll need to know some basic commands. The first thing I need to do is to get to the correct. I don't know why they added that. I think they hid they hide all of these things. Like they hide Notepad and they hide this because the assumption is you're selling to a larger and larger mass market. You're selling to people who have less and less of a need of that kind of level of control over the machine, is my belief. And so they try to make everything marketing, right? Everything was my documents, my pictures, my, in the meantime, taking away control of the machine from people. So it's there, these things are there, but you have to go dig for them. You have to know that they're there. And then you have to learn how to use them. So again, back before Windows, this was the only way we would interact with the computer, is what you're looking at now, this black screen with white, green, or amber writing. That was it. And you had to know a fair number of commands. Now, I don't need to, the commands I'm going to use, first thing I need to do is move from this directory to the directory where my files are, my Java files. And so that's CD is change directory. If I just do CD and nothing, it says, okay, you told me the change directory, but you didn't tell me where to go, so I'm not going to do anything. And remember, it was off the C drive, CS225. This was on my machine. Will be different on yours. And so now I'm in there, and then it was in M02. M02, and there I am. Capitalization doesn't matter because Microsoft built it. That was one of the worst choices, in my opinion, that Microsoft made, is not to pay attention to capitalization. Almost every other system in the world does. So if you get used to working on Microsoft and get lazy with capitalization, it'll bite your butt when you go to another system, and it will bite your butt when you're working in Java. In order to find out what's in here, I can use a dir command. So by the way, if you know the change directory command and the dir command, you're pretty much good to go. Those are all the same files that you just saw in the Windows prompt. These files are these files. Circle controller. It's just that's how it presents. And if I want to run my Java compiler after I've installed everything, I say Java C for compiler, and then I give the name of a file. Hello-world.java. And nothing happened, which is good, because what happened here is it created a new class file. If you look at the where is it? Hello-world.class. It's dated as 8/31/2020, 11:11 a.m. That file was just created. So what happened is I compiled my hello-world.java file, and it created a hello-world.class file. Even though I already had a hello-world.class file, it overwrote the old one and created and gave me the new date. Once I do this compilation, I can verify that that class file is there. Then I use the Java command to run the file. So I'm just going to be doing this over and over today and Wednesday. And what I encourage you to do is either once you get your Java and Eclipse installed, either in Eclipse, it doesn't matter, or in this command prompt like I'm doing, by all means, take the pieces of software that I gave you and run them, and then change them and run them again, and break them and try to run them again. That's how you learn. You can listen to me talk for 10 hours, and you'll learn more by playing around with it on your own in 30 minutes. So my advice is to keep running this stuff and playing with this stuff. Okay, what did Java C do? So, let me see. Right, Java C was right there. C stands for compiler. So what it did is it ran the Java compiler. So Java C compiles the hello-world.java program and creates a hello-world.class program. And what compilation is doing, let's see, I'm going to start here. Here's Hello World, by the way. We're going to talk a lot about Hello World today. I gave you this. This is part of the notes that are online for you. I gave you this, all of this code you have. This is how a Java program looks. There's no way the computer can do anything with that. That's built for humans. It's not built for computers. The computer needs to know machine language. It needs to know ones and zeros. So that means that this high-level code that we can read needs to be converted to machine language before it can actually be executed. And that's what the Java C command does. Now, technically, I'm lying to you, but it's close enough. Okay. The Java C command is taking this code and converting it into a compiled version of the code that will execute on the machine. If you have questions, by all means ask. Here, let me do this. I'm going to get rid of all these class files. There, they're gone. And if I look on my, if I do a dir here, sure enough, they're gone. Look at everything here ends in Java. Java, 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 Java. There's no class files. But now look, I'll do Java C. Actually, I can do it this way. I'll use the up arrows. Java C, hello world.java. And now I'll do another directory command. And look at, not only do I have a hello world.java, I have hello world.class. So that's what the Java C did. It compiled the code and created the class file. Now, if I want to do all of these at the same time, I do that. This little asterisk is a wildcard character. So anything that ends in .java will be compiled. And again, when people first see this, it freaks them out. When I have students that first see this, they don't like it because they said, wait a minute, it didn't do anything. No, what it did, it made all the class files. This is a successful compilation. What you don't want to see is a bunch of error messages. That's what you don't want to see. So when you do your compilation and you get nothing, that's good news. Now, in Eclipse, it's not a command type, it's a button click. Compile, compile, and run. That's a button click in Eclipse, but it's the same trick. You don't want to see any error messages come back. Okay, let's run through Hello World, which is the canonical initial program. Let me see, I'm going to do Windows. I always have to do my Windows. There we go. Space management here. All right. So Hello World, how does this look? Hello World is the canonical first program that you write when you're in beginning programming, but also don't forget, it's also a great program to write everything, yeah, all the Java files that are in that directory. That's correct, Madison. As long as they're in that same directory, that's correct. And the star is used as a wildcard, yeah. Now again, in Eclipse, once you click the button, it'll go find all your files that are related to each other and take care of it for you. The good news about Eclipse is it automatically will do a lot of things for you. And that's often helpful. And the bad news about Eclipse is it automatically will do things for you. And sometimes you need to know the details of what happened so you can fix it. And Eclipse, you know, its job is to take the workload off of you so it hides some of those details. So good news and bad news with any automated system. If you're using something like this, it's more work, you have more control. If you're using Eclipse, it's much less work, you have some less control, unless you're really learning Eclipse to the nth degree. Okay, I recommend being somewhat familiar with both. Okay. Hello World is the first program that you write in any initial programming language class, and in addition, it's a good idea just to do a Hello World type application whenever you install any new system. You'll often hear people say, oh, you know, we installed the system and we ran a Hello World. What are they saying? They're saying that they did a simple program just to make sure the system works. Anytime you install something, you know, if you want to install Python, you want to make sure that you can write the code, it compiles and it runs. So you would do a Hello World. Just, it's a basic demonstration that the system works. That's all it is. If you can compile this and get an output, the system works. So let's talk about what the elements are. First of all, remember what a class is. A class has two parts, attributes and methods. How many attributes do I have here in the Hello World class? Just yell it out.
One.
One. And what is that attribute? I have a 0. Pardon? We have 0 attributes. And then how many methods? Take a shot. We're going to say 1 from, from name. Right. Now, some people won't count main because it's good, one. So we have 0 attributes and 1 method. It's still a class, that's okay. In fact, I might get myself in trouble here. Is that a class? It's got nothing in it. Is it a class? Can I have a class with 0 attributes and 0 methods with no content at all? Yes, 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 yes. See, we absolutely can. Now, not a very helpful class, but it's a class. Okay, so let's go through the pieces here. The first thing you tell the compiler is, well, no, let me start up here. The first thing is you do a initial code block. I'm not going to push you to comment your code. In fact, I'm going to push you the opposite way. I'm going to urge you not to comment your code, but instead write good code. And don't pretend you're writing good code. Actually write good code. Just because you knew what you were doing on Thursday night doesn't mean you know what you're going to be doing, what that code was when you go back and look at it Monday morning. So write good code. But have this initial comment block. As a minimum, the class name, who you are, date created, date modified, what the heck this thing does, and then we're going to add attributes and methods as we go along. So every piece of code you turn in should have this. In fact, if you look on the rubric for the first code that you turn in for homework 1, out of 20 points, having this is like 4 points, right? It's 1/5 of the grade. Other than that, there's no commenting requirements. You can have 0 comments in the rest of your code. Good for you. Attributes go here, methods go here. So after the comment block, we tell the compiler, hey, we're going to make a class definition. We're going to design an object. We're going to design the class. So we say public class hello world. What is public telling us? What is its job? Why public? What does it mean?
Public is available for everyone to see and edit.
Exactly. Everybody can see it, right? Any other object can see it and use it, right? Not to edit, but to use it, right? And class tells the compiler what? It's a class. And hello world is which part?
It's just the name.
It's just a name. Now, this is an important name though. And you notice the hello world class is in the hello world file, hello world.java. So it has to match. Your class name here has to match the file name here. Hello world class gets stored in hello world.java. And the capitalization has to match. So if I change this to, well, let's make it work right first. So that's everyone can see it. Make all your classes public. That's appropriate. There's no reason to make a private class. Even though in your text there's private classes, it's really hard to find a good reason for that. So we're saying to the compiler, hey, we're making something. It's public. Everybody can see it. It's a class, and it's hello world. And then in between the red curly brackets, that's where the class definition goes. Then you're going to start listing all your attributes. I have none. And then you're going to list your methods. And the only method we have in hello world is a simple method that prints out the words hello world. And the way this method is written out is public static void main string args. That's called the signature, by the way. If I ever talk about the signature of a method, that's what I'm talking about, is how was it initially defined in a line like this. Public static void main string args. It's got a nice rhythm to it. And you're going to get used to it because every program you write has to have this somewhere. Those of you that came from C, you're familiar with the idea of where does the program start executing? It starts in main. In MATLAB, I don't think it's that way. Where does the program start executing in MATLAB? First line of code? Top of
Yeah.
file, yeah.
That's the beginning.
Right, at the beginning, which is, again, both of those, by the way, are an imperative paradigm. It's just that with C, not C++, but in C, instead of the beginning, it looks for main and says, okay, I'm going to start here. That main becomes effectively the top of the file. So you need to have main. You can have more than one main in your program. That's okay. You get to specify which one you want to start at. So public static void main. Main has to be there. Now, what does public mean? Public means everybody can see it. Everybody can use it, which makes sense. If you want to start the program, something outside the program has to look into the program to start it, right? So it has to be public. It's void because it's not returning a return type. We talked about that the other day. Its name is main, and it takes in potentially an array of strings. However, you're going to ignore that like 99.9% of the time. I'll have some examples where we actually use that, but when you're creating your software, your projects, and your homework, you won't use that. It is often not used, but it's there for really more sophisticated pieces of software than you would create in a course like this, as a general rule. And then, oh, wait a minute, what's the static here for? Here's what static is for. Remember, when I write a file like this, hello-world.java, remember that's the class file. And I've talked last week when we talked about objects and that there's a distinction between the class and the object, right? What's the distinction between the class and the object? The class is the design, the object is the actual thing. And how I can't run any methods in an object until I create it. But how can I run main if I have to create the object that main is in before I can use it? Does this make any sense? There's a paradox here. How can I run main before it exists? Because the only way it could exist is to create the object that has main in it, and then I could run main. But in order to do that, I had to run main, because main is where the program starts. So I have a problem on my hands. So that's what this static is about. Think about dynamic. Dynamic means changing, right? What does static mean? Never changing. So it means that this method exists. It never changed. This method exists all the time, even if you didn't create an object of this class yet. By the way, one of the complaints I have about the author in the example files in the book is that he freely uses static methods to avoid this discussion early on in the text without telling you about it. And then when your methods don't work later on, you don't know why and you're confused. What's up, Sam?
So I wanted to know if static was like the library, or if there was something in the code that kind of defines the library that we're using.
No, instead of thinking in terms of libraries, let's think in terms of what objects are pre-built and available to us. And it's not a library, it's a way of defining this method as
Not changing.
unchanging, which means unchanging to such a degree that it even exists before anything else does.
Okay, then.
Yeah.
I understand.
A library is a good way to think of things in other programming languages, but I don't think of them so much as libraries here as objects that are available to us. And trust me, even in this, we don't need to care right now, but there's a whole lot of horsepower of pre-existing objects that are built within the language that have to operate in order for even this simple example to operate. And normally we never care about those guys. They're just part of the Java environment.
Got it. Thank you.
Okay, so that's what this is. And all of this is about the name. And again, public static void main. It's a good thing it has a nice rhythm, right? You'll it'll just tumble out of your fingertips and you know, off your tongue once you get used to it. And the only thing it does is it prints out hello world. That's what hello world does in every language. Prints out hello world. Some authors will use, you know, programming is fun or Java is fun, and, you know, burn those books, right? It's hello world. I'm a traditionalist. It's hello world. So all that's happening here is we're printing that out. Now, what is all this mess going on about printing out? Well, remember I said there's a lot of objects that we don't even know exist yet that need to work in order for this simple piece of code to work. That's one of them right there. The actual method, and again, those of you that took C are probably used to printf and maybe println and things like that. In MATLAB, how did you print something out? Did you say print or write or something like that?
It was fprintf.
Fprintf. So that's the same thing, println, which is basically it's print a line of code. It's not formatted. There is a printf format you can choose to use, but we don't need one here. It's println, which is print a line out, and you automatically get the line feed at the end. That's what the ln is doing for you. That's the actual method that you care about. What's this system.out stuff? Oh, these are objects that you already have available to you. There's a huge object called system, and its job is to interact with the computer system, to interact with the operating system. So anytime you're dealing with input and output, you're probably dealing with system. And by the way, system.out, in other words, you're dealing with the part of that object that pushes things out, not input, but output. So these are actually objects that already exist for you. And Java has just thousands of objects that already exist for you. Part of being learning the Java programming language is learning what already exists. How would you possibly know? That's why I say the way to learn this stuff is to actually do it and play and say, hey, I need this, that, and the other thing. Oh my. I didn't do that. I'm not sure who was doing that. So what's happening here is there's an object called system, and then that system has an object inside it called out, and then that object has a method called println, and that's what these dots are. So everything is separated by dots, and you'll get used to this pretty quickly. When you're dealing with things in an object, remember, objects have attributes and objects have methods. Well, how do you grab a specific attribute? How do you grab a specific method? You do it with this dot notation. So this line could be read as, there's an object called system, and inside that object called system is an object called out, and that object called out has a method called println, and it basically prints out whatever you tell it to print out inside the parentheses, and that's what it's doing. And because we've done this, it compiles, and then I run Java. And again, in Eclipse, this is like one button click, right? Compile and run is one thing. And ta-da, it says hello world. Now, I've given you this file, and all these files I gave you. I also created, for now, and I won't do this throughout the whole semester, but for now, I've created a version called annotated. So hello world annotated, it's the exact same amount of code, but look at all the comments I put in here just so you could walk through and remind yourself what it all means. The lines of code in here are the same that actually execute, but I gave you lots and lots of comments. So in the annotated versions of these, I gave you an annotated circle, an annotated circle object, all the files that we're going to talk about this week. I gave you an annotated form and in non-annotated form. So you can look at these with all of the explanatory comments right in there in the code. Okay? Let's make the main method private. I'm saving this. I'm going to recompile. And then I'm going to run it. And it says, the main method was not found. in class hello world. Please define the main method as, it's nice they say please, right? Public static void main string args. See, they tell you what to do right here. Why couldn't it find the main method? It's static, right? Why couldn't it find it? Because I made it private. And this is what I'm talking about when you're going to run your own code. When you're looking at these example pieces of code, the example software that I give you, do that kind of stuff. Change it. What if instead of void, I change this to int? Will it compile? Will it run? I save it. I compile it. Oh, it doesn't like it. Missing a return statement. Do this kind of stuff. Break it and then fix it. What if I said, I call it Hello World 01? Instead of Hello World. And then I try to compile it. It doesn't like that. It says, class Hello World 01, right? There's my error message. By the way, read these error messages. They actually do tell you what's wrong. Hello World 01 is public. Should be declared in a file called hello world 01.java. Okay. Make sure I don't break it for real. Okay. This is the kind of thing I'm talking about. When you do these files, don't just look at them, run them, and then change them. If you're lucky, you'll break it. And then if you break it, you learn something. Oh, wait a minute, why didn't that work? Okay. Once you get Hello World working, what that means is your system works. Now you can start to do, you can do Hello World, you can do pretty much anything after that. So the next class that I did was a basic, simple operation, a basic, simple, calculation, just to show you how to create and assign variables. Oh yeah, this is something that I need to put in the notes. Every programming language has to declare variables, assign values to variables, allow for if then else or other forms of selection, allow for loops or other form of repetition, and then do input output. I don't care what programming language you're looking at, what paradigm you're looking at, every one of them has to do those 5 things. I keep meaning to put these in the notes, and I will. Which means when you're learning a new language, that's the way you should approach it. Learn how to declare the variables, learn how to assign values, then learn how to do if then else, then learn how to do loops, then learn how to do IO. We're going to do assignment to variables here, a declaration and assignment in this file. And then next week we'll do if then else and loops. And then we'll work up to IO, which is always the ugliest part of every language. We'll spend several weeks on JavaFX. Okay. So if we walk through this again, this is going to be, now I'm going to start not going through these in such horrible detail, right? Public class first circle and public class, right? This just starts to be normal, and to you starts to feel more, oh yeah, that's what I expected. In fact, as soon as you saw that thing was called firstcircle.java, you knew the name of that class was first circle because the class name has to match the file name. And all I did here, this is the class, and if you want to, you can put comments, things like this. Because sometimes you lose track of these things. This This is basic stuff. So again, I have no attributes. I have variables inside the main method, but I still don't have any attributes, which tells you what? I'm doing this for an example to give you an idea of how to declare things and how to assign to them, but we're not doing any object-oriented stuff yet. If we were, we'd have attributes. So we're going to work our way to those object-oriented things by the end of tomorrow's lecture. So, good old public static void main string args. And inside of that, I start to declare variables. I then assign values to variables, hard-coded, worst way to do it, right? And then I print things out. So this is a little bit more sophisticated than hello world. Not much, just a little bit more. Now, hopefully you have questions about this stuff. What am I saying here? X location, Y location. I named it the same as the sheep and the dog, right? X location, Y location. Int. So we're talking about an integer-based X location, Y location. That's what that's saying. I did not put a visibility modifier on it. I did not make these private. I keep telling you, make your attributes private, make your attributes private. And here I just declared two things and didn't make them private. How can I get away with that? It's not an instructor thing. What do you think? Let me ask you this, are they attributes? $50-50 shot.
Yes, they're attributes.
They are attributes, and we have a yes, and they are part of a method. Ah, they are part of a method. Yeah, so what does that mean, Gabriel? Right, attributes go here. Right? Attributes are not declared inside of a method. Attributes go here, prior to any methods. So they are not attributes, those are variables inside the method. And because they are variables inside the method, I'm not going to worry about visibility modifiers. The scoping rules of how things work inside and defining things inside methods will take care of that for me. So you don't need to worry about your variables, but all of your attributes make private. Those go here though, outside of the methods. That is a normal, it's normal for this to take 2-3 weeks before you make that distinction. That's normal. And maybe normal to go longer than that too. So these are an integer, X location, Y location. They are variables that are local to the main method. They're inside the main method. They are not attributes of the class. And then I let radius be double. Remember what double means? That's still numeric, but now you're allowed to have, it's not integer-based numeric. And then I just, it's that easy to assign values to these things. You could have done it on the same line of code, int X location. I could have done it this way, int X location equals 20. I could have done that. I don't like that. That's personal style. I like to declare my variables in one place and then initialize them in another. And the reason is as you get more and more sophisticated with the classes, with the methods, your initialization is going to get more ugly and complicated too. So I like to keep it separate from the declaration. And then all I did was print this stuff out. Okay, now look at the print statements here. System.out.println, you're going to get used to that. You're going to see that all the time. And here's the quote, circle center is at, that's inside the double quotes, so that's just a string. And then plus X location. So what I'm allowed to do inside the print statement, it's pretty easy to concatenate things together. I use the plus sign as a concatenation. Now, I forget, in MATLAB, is it the same way? It wouldn't surprise me. It's this way in JavaScript, Java. How about Python? Does anybody know? How about C? I can't remember. I think in C, it's not this way. When you printed things out in MATLAB, was it this format or was it something else?
I know in Python it's plus.
Okay.
Yeah, that's what I was gonna say.
And I think as long as you're using, if
Yeah.
you're using, it was just the single quotes. I don't think we need plus
Yeah.
MATLAB. For MATLAB, it was, okay, it might have been comma separated. Again, different languages will do it slightly differently, but it's the plus sign. Now, if you're doing printf and you're trying to get really fancy formats, it'll be different, but this is nice, quick, simple, dirty, it works. So you're able to construct these things. And then circle area, I'm just doing radius times this thing, math.pi. Oh, what's that about? So remember I said there's a lot of objects that you already have access to. How do you know? Google, Oracle help pages. You find out you might need it, and so you start looking around to see if it exists, and it probably does. There is something called, how would you read that thing? It's math.pi. We know what its job is, right? Because it's called math.pi. Its job is to give you the value of pi. It's capital P, capital I. So what is that telling you? Anything? It's a constant. And math.pi, what is that telling you? There's something called the math object. It's been built for you. You don't need to worry about it. You got it for free. You have a math object, and it has inside of it, it has a constant called pi, math.pi. How do you know? Well, no matter what programming language you go to, they're going to give you a way to get pi and to get random numbers and things like that, right? So you just Google, okay, what's the syntax for that? The math object you will use a lot if you're going to do random numbers, rounding numbers, trig functions, powers, raising things to a power. There's a reason I did radius times radius, because if I wanted to raise it to a power, I had to do something like math.power radius comma 2 or something like that, and it wasn't worth it. How do you know all this? Well, you don't. That's why Java is new to you. Now, in order to learn this, remember I did give you a couple of tutorial pages too. The tutorials point, the textbook that we have, WW3 schools are good. Google is fine. So you do not use Square. We can try it, but I don't think it'll work. Yeah, I was very disappointed that Java didn't support that directly. Because almost everybody else does. But Java doesn't like it. So, how do you find this stuff out? That's what you learn whenever you're learning any programming language. You can get the basics of it pretty quickly, and then each language has some kind of an unusual thing. Like some languages like to call their random number function random, and some of them like to call them rand, and some of them like to call them rnd, and some of them like to call them rdm, right? Who cares? You Google that stuff. You know they have it. And so you Google that stuff. It's the same with this. Okay, I'm going to run this real quick, and then what we'll cover on the next, on Wednesday, is the circle with input, and then circle object and circle controller, where we're actually doing objects for the first time. So what's happening here is it's just hard-coded, prints it out. And then what happens with circle with input, we actually get input, but I need more than a minute to talk about that stuff. So I'll talk about that stuff on Wednesday. But if we run this here, Java, I want to make sure it works. And then Java first circle. And by the way, if I didn't capitalize that right, it wouldn't work. And what do you know? It's just the hard-coded values that I put in there. So hard-coded values, now we've got, we're building complexity, right? First, we could just run a program that said hello world. Now we're running a program that can have variables and assign values to variables and tell us about them, but we can't change them yet. So now the next thing is to get user input so we can actually assign, the unique variables every time we run, assign values to them. And then we're going to move into having objects from there. You have access to this code, both the annotated and non-annotated versions. look at it, play with it. If you have your Java JDK running and you don't have Eclipse set, you can run it with console. But my advice is to play with it, break it, and then fix it. You haven't tested it until you broke it, right? Okay, I will see you guys on Wednesday. I appreciate you being here. I'm going to lots of us. This is excellent. Have a good day, guys.
Yes, sir. You too.